Okay, so you picked up 2 pink packets today. That goes along with, you already had a pink 5.3 to 5.4 worksheet. Looks very similar to this one right here. Okay, 8 problems, 5.3, 5.4. Okay, that is going to be due on the 27th. On top of that, you also had a pink law of signs discovery sheet. Looks like, yeah. Anyways, you got one. I don't know what happened to it. Anyways, you got a pink one. Pink law of signs discovery sheet. Can I borrow yours? Okay. Looks like this. Okay. Also due 27th. Then today you got a law of cosines discovery sheet. Looks like this. Actually, it's a packet because we like to kill trees in this one, right, Dr. Erdman? Pi over 2. Pi over 2. Okay. Right. We're going to talk about this today, and then you're going to finish most of this today. Then you also got a ginormous packet that has a worksheet for 5.5 to 5.6. It's got a worksheet for 5.3 to 5.6, and it's got a review worksheet right for the test on the 27th. All 4 of those are going to be due because they're all on pink paper. Pink is the favorite color this particular unit. All due on the 27th. Okay? Tomorrow we will be handing back formatives for you so that you can get to work on those. Next week, Tuesday, you have another formative, and we're going to start word problems. Okay? So plenty of stuff to be doing here in the next few. In terms of the packet, the homework packet that you got today, you can do anything in there with the exception of the word problems. And if you want to try the word problems, go ahead and try the word problems. Okay? But we're going to focus in on word problems next week, Tuesday and Wednesday. Okay? All right? Sounds like a plan. So, then, today, we're going to start talking a little bit about the law of cosines. Now, the actual proof for the law of cosines comes out of a quadrant 1 triangle, okay, where we can find the coordinates of point B based off of that particular triangle and put them all in. Okay? So we're basically trying to find the length here of side A. Okay? And so that distance comes out of the Pythagorean theorem because it's in a right triangle, and that little mini right triangle over there on the right side, it comes off of the Pythagorean theorem where we square one of the small sides, square the long side, and then take the square root of that after we add those two together to get the length of the hypotenuse. Okay? So it comes out of this. You saw it many times when you were in geometry as just a squared equals b squared plus c squared minus 2bc cosine of a. Okay? That pattern also works for the other two. So I could write this also as b squared equals a squared plus c squared minus 2ac cosine of b. I will be honest with you, it wasn't until a few years ago that I actually finally memorized the law of cosine, because I had always just memorized the pattern. Okay? And the pattern is that when you write it out, it's bookended by the same letter. A is over here, A is over there. B is over here, B is over there. Okay? It's bookended by the same letter, which means that if C is over here, this one is going to end with cosine of C. Then in between are the other two letters. First we square them, then we multiply them. Oops, that should be B here. Okay. Now, a couple of notes on the law of cosines. The law of cosines is needed for us because if we are in a side case, we would use it. If we are in a side case, we need to use it. Okay? Because we don't have in either one of those cases, we don't have that one complete fraction for the law of sines. Okay? Now, if you are thinking along the same lines as Schmeling, he says use the law of cosines 3 times in one particular problem. Okay? If you think along the lines of Mrs. Hill and I, you only have to use the law of cosines once, and then you can use the law of sines after that, because if you use the law of cosines once, you now have that complete fraction in the law of sines, and you can use the law of sines then after that. Okay? Okay? However, I will tell you that whenever you do find an angle, with the law of sines, with the law of cosines, you find the biggest first. Okay? With the law of cosines, we're going to find the biggest angle first. Because law or inverse cosine lives up in quadrant 1 and quadrant 2, which allows us to get an obtuse angle. So if we find the biggest one first, then when we go to the law of sines on the second to find the second angle, it's there for us in the land of sine, which is quadrant number 1 and quadrant number 2. Okay? So really it's only quadrant number 1. So we're going to find the biggest angle first with that one. Okay? Then if you turn your page to page number 2, down towards the bottom there, I kind of want to go through how we, in a side case, there's 2 things that needs to happen. Actually, what I need to do here is I need to bring this one up here first, and we first need to talk about this. In the side case, you've got to check to make sure that it's a triangle first, okay? Because you don't know an angle yet. So the sum of the 2 shorter sides has to be greater than the longest side. Okay? So you look at your 3 angles, or your 3 sides, excuse me. So for instance, in number 3, the 3 sides were 3, 5, and 6. Okay? So I look at the 2 shortest ones, 3 and 5. I add them together, and those 2 have to be longer than the third side. 3 plus 5 is 8. 8 is bigger than 6, so therefore it can be a triangle. Okay? If it is a triangle, then you can go on. If it's not a triangle, then you're done. You can't do anything because it doesn't make a triangle. So that's why finding the triangle, or to seeing if it is the law of cosines, or excuse me, if it is a triangle first, is so important. Then, if we take, so now if we're in a side case, we've got to find an angle. And so what happens here is we got to do a little bit of algebra first. And our first algebra is going to be, we're going to subtract off b squared from both sides. And we're going to subtract off c squared from both sides. Okay? All of a sudden it changed on me because I changed the angle. Okay? If I do that, whoa, it's here too. Oops, that breaks. Oops, wrong one. Okay. If I do that, then I get a squared minus b squared minus c squared equals negative 2 bc cosine of a. Alright? Now I want to get the cosine by itself because then I can use inverse cosine of that, whatever that is, to then find that angle. So if I'm going to do that, then what I'm going to do is I'm going to divide everything by negative 2 bc. Let me ask you this question. Can I cancel out a b on the left side? I will also ask the question, can I cancel out a c on the left side? Based off of that, based off of your algebra knowledge, can I cancel out a b? Can I cancel out a c? Yay or nay? Nay. Bad maths. Okay? Bad maths. Okay? Over here on this side, because they're all being multiplied, yes, this negative 2 cancels out. Yes, this b cancels out. Yes, this c cancels out. Yes, on that side to all three of those. But on the left side, none of those can cancel out. Okay? The only thing that I can do is I can make it look prettier by not putting that negative sign down there. And I do that by going b squared plus c squared minus a squared all over 2bc. I just change the signs. I multiply the entire numerator by negative 1. Okay? Now, all of that math is going to be the same to get cosine of b, so I don't have to do all that math again. I'm just going to replace a with b. I'm going to swap positions with a and b. If I swap positions with a and b, then this would be a squared plus c squared minus b squared all over 2ac. To find c squared, or excuse me, to find the cosine of c, I could swap positions with b and c. A squared plus b squared minus c squared all over 2ab. Okay? With that being said, what I would like you to do now is I would like you to continue working on the rest of the packet. You will have to go back to the first page, and you need to fill in that one because that is going to be checked. And then start at that middle of the, so start at example number 1, work your way down. There's some filled in, or there's some notes off to the side for you to remember and look in your notes to find and all that fun stuff. You need a calculator, and you have the rest of the time to work. I do have an answer key up front if you would like to come up and check work as you're going along.